Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is maximize the number of target nodes after connecting trees. Now the problem category is of hard level, but I would say once you watch the video, understand the problem and the solution approach, and if you have a basic understanding of trees and graph, then this question is going to be really easy for you instead of hard. Now I know that the description of the problem is really bad, but let me explain you what the input is all about and how to get the output, and then we will understand everything about the question in depth, and then we will see the solution. So the given input in the problem is edges of two trees. So basically we are given two trees in the input, and in the input we are given the edges of the trees. These edges are two-dimensional arrays. So in the input there are two-dimensional arrays, and these arrays are actually the edges of the trees. Now each edge looks something like this, which is an array of two elements, node 1 and node 2. And this edge, what this is telling us, that node 1 and node 2 are connected. That is, we can go from node 1 to node 2 or node 2 to node 1. Now in the output, what we need to give is, we need to give the output as an array of n integers. Now we need to understand it step by step. This given n, this n is the number of nodes in the given tree 1. So we know that we are given two trees, right? So we need to find an array of n integers, and this n is the number of nodes in the first tree. For each element at index I, what's the value we need to give? We need to give the maximum number of target nodes to node I of the first tree. Now I know that this is sounding confusing, but we are going to understand it in depth using the example. So just stay with me. We are going to see everything in detail. So coming back to the output again, we need to give the output as an array of n integers, where n is the number of nodes in the first tree, and each element in the array of n integers at index I will be the maximum number of target nodes to the node I of the first tree. Now the thing is, if the first tree has n elements, let us say 5 elements, then we will have an array of 5 elements, index 0, 1, 2, 3, 4. Now what is this target node? I will explain you. Before that, you need to understand that we need to find the maximum number of target nodes to every node in our first tree, right? And we need to create an array of it and give it as an output. Also, what we need to do is we need to connect one node from the first tree to one node from the second tree. That is, we have two different trees, right? We need to connect those two trees using just one edge, and then we need to find the maximum number of target nodes to every node I of the first tree. So we need to connect our tree using one edge, exactly one edge, okay? And now let us understand what is this target node. Now let us say that we have two nodes, u and v. Now u is a target to v if the number of edges between u and v are even. The thing is, if there are two nodes in a tree, then you will say that this node is a target to this node if the number of edges between these two nodes are even number. Okay, if the number of edges between them is 0, 2, 4, 6, even number, then this is going to be a target node to the node I. Now let us try to understand it using an example, and everything is going to be clear. Now first of all, we need to see the input, right? So coming back to this, what is the input we have? We have the input as edges of the two trees, and these edges are 2D arrays. We have got two 2D arrays, and in each 2D array, the edge is something like this, an array of two elements, the node number 1, the node number 2. So coming back to the input, we are given an input of two-dimensional arrays, edges 1 and edges 2. This is for the first tree, this is for the second tree. Each edge is telling me that 0 is connected to 1, 0 is connected to 2, 2 is connected to 3, and 2 is connected to 4. Each number like 0, 1, 2 or 3 or 4, these numbers are denoting a node in the tree. So there are edges which are given for the first tree and the second tree. So let us see how the tree will look like. For the edges 1, that is for the first tree, you have a 0 and 1, right? So you will create a node 0 and then connect it with node 1, right? Then you have 0, 2. So you have 0, connect it with 2. Then you have 2, 3, connect 2 with 3. Then you have 2, 4, connect 2 with 4. This is how your tree will look like. And now you will notice that if this is my tree, it has total 1, 2, 3, 4, 5 nodes. Then how many edges it have? It has 1, 2, 3, 4, which is given in the input as well. 1, 2, 3 and 4. 4 edges. It means that if you have 4 edges, you will have 5 nodes. If you have 10 edges, you will have 11 nodes. One more than the number of edges will be the total number of nodes. Similarly, for the edges 2, that is for the second tree, you have 1, 2, 3, 4, 5, 6, 7. Total 7 number of edges. So you will have total 8 number of nodes. So 0, 1, 2, 3, 4, 5, 6, 7. Total 8 number of nodes are there. And the edges are 0, 1, then you have 0, 2, then you have 0, 3, then you have 2, 7, then you have 1, 4, then you have 4, 5, then you have 4, 6. So these edges are creating a tree something like this. Now what do you need to give in the output? Let us try to understand it again. In the output, we need to find an array of n integers. N is the number of nodes in the first tree. So in the first tree, we have total 5 nodes. So we need to give the output as an array, which will have total 1, 2, 3, 4, 5 elements. And then you need to understand that output at index I, that is for each node in the first tree, there will be an output. And that output is going to be the maximum number of target nodes to the node I of the first tree after you connect both the tree using one edge. That is, you connect one node from tree first to one node from second tree. So you basically need to connect both these trees using just one edge. And then you need to find out what is the maximum number of target nodes you can have for each node 0, 1, 2, 3, 4. For this particular input, the output is 8, 7, 7, 8, 8. Now, what this number is denoting, it is telling that for node 0 in the first tree, the maximum value of target node is going to be 8 when we connect both these trees using one edge. Now let me show you how the output will be 8 for the node 0. So what we can do, we can actually connect 0 with 0. So now this is our whole graph. Now you need to find out what's the maximum number of target nodes we will have for this 0, for this particular node. The answer is 8. Let us see how. For this 0 itself is a target node because the distance between both the nodes are 0. If the distance is 0, it is a target node. Basically the distance or the number of edges has to be even. So 0 is also considered to be even for this particular problem. So we have got a node 0, and then this 3 will be a target node and 4 will be a target node because the distance between 0 and 3 is 2. Number of edges are 2. 1 edge and 2 edge. Similarly for 4, if you want to see the distance between 0 and 4, it is 1 and 2, 2 edges. Number of edges is even, right? So if the number of edges between two nodes are even, it is a target node. So for 0 it is 0 itself, then 3, then 4. Now let us come back to the other tree. Since this tree is now connected with this particular edge, so the distance between 0 and 0 is 1, which is not even, right? So 0 is not going to be the target node, this 0. But 1, 2 and 3 are going to be target nodes because the distance between 0 and 1, 0 and 2 and 0 and 3 is 2. There are total 2 edges between these two nodes, 1 and 2. This second, this second. This is the second edge with 2 and 3. So 1, 2 and 3 are also target nodes. 0 and 3 and 4 are also target nodes. And you have 5 and 6 which will also be a target node because the distance between this 0 and 5 is 1, 2, 3, 4. 4 is even, right? So this 5 is also target node and 6 is also target node because from 0 to 0 this is 1. Then you have 2, 3 and 4. So if you have number of edges which is even, then it is a target node. So for 0 it is 1, 2, 3, 4, 5, 6, 7 and 8. That's the answer, right? Let us see for some other node. Let us see for 2. Now if you want to find for 2, let's delete this edge. Let's try to do the processing for 2. If you want to find the maximum number of nodes for 2, then it will be 1. 1 is going to be a target node because the distance between 2 and 1 is 2. Why? Because this is 1, this is 2. The distance is 2, which is even. So for 2, 1 is a target node and 2 itself is a target node because the distance between this 2 and 2 is 0. And if the distance or the number of edges are 0, then that will be a target node. So now you have 1 and 2 target nodes. And what you can do, you can connect this 2 to 0 again. And now from 2, 1, 2, 3, 5 and 6. All these are going to be the target nodes because the distance is even. If I connect this 2 with 0, then from 2, you will notice that this 1 is having an even number of distance or even number of edges. 1 and 2, 1 and 2, 1 and 2, right? Similarly for 5 and 6, it is going to be 1 and 2 and 3 and 4, 1 and 2 and 3 and 4. So the number of edges between 2 and 1, 2, 3 and 5, 6 are even, right? So for 2 it is 1, 2, 3, 4, 5, 6, 7 and that's the output. So this is what we need to find. We just need to connect both the trees with one edge, and for each of the node for the first tree, we need to find how many maximum number of target nodes we can have. And now I think you understand the target nodes. For any node, some other node is going to be a target node if the number of edges between both the nodes are even. So now let us see the solution approach. Now before I move to the solution approach, I'm going to tell you the simple trick to understand if a particular node is a target node to some other node or not. We need to understand two things. First is how many target nodes we are going to have for each node in the same tree, and then when we connect both the trees, how many target nodes are we going to have for each node in the other tree. That's the two things we need to know, and I will tell you why. First of all, try to understand for the same tree. If you want to find out how many target nodes we have for this tree in this same tree, then the trick is going to be you first assign each node a depth or a level. So this is at depth 0, this is at depth 1, this is at depth 2. Now all the nodes on the even depth, that is 0 and 2, are going to be the target nodes for each other. All the nodes at odd depth are going to be the target nodes for each other. And why I am saying this, 0, 3, 4, they all are going to be the target nodes for each other because their levels are, or their depths are 0 and 2. 0 and 2 both are even, so they are going to be the target nodes for each other. For 1 and 2, they are going to be the target nodes for each other, and that's because they are at the same level, or better I can say that they are at a level 1 which is odd. So all nodes which are at odd depth are going to be the target nodes for each other. And now you see how can we say that for 1, this 2 is at the same level, right? To reach this 2, you will have to travel through even number of edges, because if you want to reach this 2, you will need to go up and then down 2 edges, right? Similarly for 2, 1 is going to be a target node. How can you reach from 2 to 1? You will say 2 to 1, right? 2 number of edges. Or let us see for 3. For 3, I am saying 4 and 0 are the target nodes apart from 3 itself. How can we say this? For 3, you will have to travel one node up, one node down, total 2 times, right? Or 2 edges. Then 4 is going to be the target node because we need to travel 1 and 2, 2 edges, which is even. And then you have 3, then 0, total 2 edges, right? And then for 3 and 0, you can say that you can go from 3 to 2 and 2 to 0, 2 edges. That is even number of edges. So basically, all the nodes at even depth will be connected or will be a target node to each other. All the nodes at odd depth will be a target node to each other. Let us see the same example for the second tree, and then you will understand the same concept better. For the second tree, what you need to notice is 0, 4 and 7. They are at even depth because they are at a depth of 0 and 2. 1, 2, 3, 5 and 6 are at odd depth because they are at a depth of 1 and 3. So the depth of 0 is 0, 4 and 7 is 2. Both are even, right? 0 and 2 are even. For 1, 2 and 3 and 5 and 6, the depth are 1 and 3. Both are odd. So what I am saying is, for any nodes at odd depth, that is 1, 2, 3, 5 and 6, they all are target nodes to each other. Let us see how. Let us see for 5. For 5, I am saying that 5 itself is a target node because the number of edges between 5 and 5 is 0. For 6, you can say you need to go 1 up, 1 down. Total 2 edges you need to travel. And so you can say that 6 is also a target node to 5. For 1, you can say that you need to travel 1 and 2 times, which is even. For 2, you can say that you need to travel 1, 2, 3 and 4. That is 4 times, which is even. And similarly, for 3, you can say that you need to travel 1, 2, 3 and 4. 4 times. So 5 and 3 are also target nodes to each other. So basically, we need to do the same thing for 2 trees. We need to find what are the number of nodes in both the trees at even level and at odd level. And then we need to find out for each node, are they at even level or are they at odd level? So let us see how we can do it. So now let us go to the solution approach. First of all, we need to create an adjacency list for both the trees because we are considering both the trees as graph. And then we need to find the value of n and m. N is the number of nodes in the first tree. M is the number of nodes in the second tree. So for n, it is going to be the length of edges 1 plus 1. And for m, it is going to be the length of edges 2 plus 1. Now we create an adjacency list for both the trees, which is going to tell us that what are the different nodes we can reach from a particular node. So for the first tree, we can say that from 0, we can go to 1 and 2. From 1, we can go to 0. From 2, we can go to 3 and 4. From 3, we can go to 4. And from 4, we can go to 3. That's what the tree we have. From 0 to 1 and 2. From 1 to 0. From 2 to 0. From 2 to 3 and 4. From 3 to 2. And from 4 to 2. Similarly, we will create the adjacency list for the second tree, which is going to tell us that for each of the node in the second tree, what are the different nodes we can reach. Next is, we need to create parity count and per node parity for both the trees, where the parity count is the number of nodes at even and odd depth for both the trees. So basically, this is going to be an array of 2 elements. The first is going to store the number of elements at the even depth. The second element will be the number of elements or the number of nodes at the odd depth. And node parity is something which is going to tell us that for each of the node, is it at even or is it at odd depth? And how this is going to help us, I will show you. So for tree 1, the parity count will be 3, 2. That is, we have 3 nodes at the even depth, 2 nodes at the odd depth. And the node parity is 0, 1, 1, 0, 0. So basically, these numbers are the nodes. So we have 0, 1, 2, 3, 4. These are our nodes. For 0, it is 0. For 1 and 2, it is 1 and 1. For 3 and 4, it is 0. 0 means that this particular node is at even depth. 1 means that this particular node is at odd depth. And same for the tree 2. The parity count is 3 number of nodes at the odd depth, 5 number of nodes at the even depth. Node parity is telling us that node number 0 is at even depth, node 1, 2, 3 are at odd depth, then we have node 4 which is at even, then node 5 and node 6 is at odd depth, and node 7 is at even depth. And same thing we can see from the trees. For both the trees, we can see the same thing as well. For the first tree, the number of nodes at the even depth are 1, 2 and 3. And the number of nodes at the odd depth is 1 and 2, 3, 2. And for the second tree, the number of nodes at the even depth is 1, 2 and 3. The number of nodes at the odd depth is 1, 2, 3, 4, 5, right? And now the output is going to be the result for each node in the first tree, right? So this is the parity count for the tree number 1. And this max is 5. What is this max? This max is actually the maximum value of the parity count for the second tree. And that's because the thing is, let's come back to the tree diagram again. We need to find the number of target nodes for each node in the first tree, right? So for each node in the same tree, what is the number of target nodes we have? If the node is at odd depth, then all the nodes at the odd depth, right? And if the node is at even depth, then all the nodes at the even depth. This is the number of target nodes in the same tree. And for the other tree, the number of target nodes is always going to be the same because we are actually trying to find out the maximum number of target nodes, right? For the other tree, our target nodes can either be at even depth or it can be at odd depth. So we will connect our node from the first tree to the second tree in such a way that we always pick up the maximum number of target nodes from the other tree, right? So in this case, we have 3 number of nodes at the even depth, 5 number of nodes at the odd depth. So we will try to connect our trees in such a way that we can get all 5 number of target nodes as our target nodes. For example, if I want the target node for 0 from the second tree, we are going to connect it with 0 or 4 or 7, because if I connect it with 4, 7 or 0 and they are at even depth, then all the nodes at odd depth are going to be my target nodes for this particular node. Why so? Because we are using one edge to connect with the other tree, then we will use another second edge to go to some other level. So we will always have even number of edges between our node and other levels, right? And that is why we are saying that for the second tree, I have the parity count as 3 and 5. I will always connect both the trees in such a way that I always pick up the max value. So I have a max value of 5, which is the maximum of the parity count for the second tree. Then for each of the node in my tree 1, the 0, 1, 2, 3, 4, all my 5 nodes, these are the node parities, which is 0, 1, 1, 0, 0. The node number 0 is at even depth. At even depth, we have 3 number of nodes, so this is going to be 3. The node number 1 is at odd depth because it is 1. So we will say at odd depth, we have total 2 number of nodes, so this is 2. At odd depth, we have 2 nodes. At even depth, we have 3 nodes. At even depth, we have 3 nodes. So these are the number of target nodes from the tree 1 plus 5 to all the values, because for each node, we are going to fetch the maximum number of target nodes from the second tree. We need to just add this value and the output is going to be our final answer, 87788. And guys, I know this is a bit complex to understand. Make sure that you understand it step by step. Do not try to understand everything at once. Try to understand it step by step and everything is going to be clear. So let me take you back to the code editor and let me show you how the code will look like in Python. So this is the complete code in Python for this particular problem, and let me show you the code one by one. First of all, we need to find the value of n and m, which are the number of nodes in the tree 1 and the number of nodes in the tree 2. Then we create the adjacency list for both the trees using the function makeList, in which I just pass the edges we have for each tree and the number of nodes, and then we create the adjacency list. Once this particular list is created, we have adj1 for the tree 1, adj2 for the tree 2. Then we create a parity count 1 for the first tree, which is initially going to be 0, 0. This 0 is telling me the number of nodes at the even depth. This 0 will store the number of nodes at the odd depth. This node parity 1 is going to store for each node in my tree 1, it is going to store whether it belongs to the even depth or it belongs to the odd depth. And then we create a function DFS, which is going to actually count these values, parity count 1 and node parity. We will do the same operation for the second tree, parity count 2 and the node parity 2. So let us try to understand the DFS function, in which we have a node. Our current node is the first node, the node number 0, whose parent is going to be -1, that is, it doesn't have a parent as of now. Then it has a depth of 0 for now. And then the adjacency list which we have created, then the initial parity count, which is 0, 0, and the node parity, which will be 0 for all the nodes for now. Then we will calculate parity value. This parity is going to be depth mod 2, which is going to calculate the current depth. Is it even, is it odd? So for 0, 2, 4, 6, 8, all these values, this parity is going to be 0, right? And for 1, 3, 5, 7, all the odd values, this parity is going to be 1. Then we calculate the parity count, and we will say parity count at the index 0 or index 1 based on the depth, whether it is even or odd. We will add +1 to it. So this is going to calculate how many nodes we have at even depth, how many nodes we have at odd depth. And then node parity for the current node is going to be equal to parity. Parity means it will be 0 or 1, 0 for even depth, 1 for odd depth. So this is going to store for each node whether it belongs to even depth or odd depth. Then for all the neighbors for my current node, we are going to call the DFS function again with depth +1. But the thing is, we are going to say if neighbor is not equal to parent. That is, we know that the trees are undirected, right? So we don't want that if we process for the node 0, then we process for the node 1, then node 2, and 2 is also connected to 0. So we start processing for 0 again. So do not process for the parent because we have already done the processing for it. So this is to make sure that we do not do the same thing again and again. And then this function is going to calculate the parity count and the node parity for both the trees. Once it is calculated, we need to find out the maximum parity for the second tree, because we are going to connect both the trees in such a way that for the second tree, we always fetch the maximum value. Then create an array result and run a loop for n times. Calculate the parity value for the current node using the node parity 1. It can be 0 or 1. That is, it can belong to odd depth or it can belong to even depth. And based on that, count the number of nodes from the parity counts array, which is storing our number of nodes at even and number of nodes at odd depth, plus the max parity 2, which we are getting from the second tree, and then append this count into our result, and that is going to be the complete solution. We can just return the value of result, and then we can submit this code, and this is going to be the complete solution for this particular problem. And you can see the runtime is good, the memory used is good, so we have solved this particular problem. And I know guys, this particular solution is actually very complex, even the solution approach is complex, but I would say do not focus on the solution, focus on both the trees, that is, go on this diagram, try to focus on this diagram and try to understand, try to visualize the answer, try to see what is the difference for the nodes at even depth, at odd depth, and this is where you are going to understand the solution. So that's it for this video guys. I hope this particular video helps you to understand the problem and the solution approach as well. And if it did, then make sure that you hit that like button. And if you are not subscribed to the channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching this video guys.